Hi, I'm Lian Marie Barangco of BS ECE 3C, and for ECE 23 or Communications 2, we are going to know what's PWM or Pulse Width Modulation, how it works, and specifically NBDS, which is our assigned scheme for today's discussion. So what is PWM? PWM, which stands for pulse width modulation, is an analog pulse modulation that is characterized by the use of reference information signal to be changed into the characteristics of a digital carrier pulse. So here's the example that is where we use the PWM. It is to change the analog signal to digital signal. PWM schemes or techniques. So today we're going to discuss about NBDS. This PWM technique or natural sampled BD single-sided modulation stands for NBDS. Its sampling method is natural, so it's under NPWM, and it is single-sided but with 3 BD levels. So we are going to explain this further by gathering observation in the digital output signal. But first, waveform reading. We base the readings of the waveform by which of the two is higher. It is either the analog input or the sawtooth. And next, it indicates the positive and negative part or level. Here in differential mode, we derive the differential mode signal by subtracting the side B from side A. After getting the difference, we need to get the average or divide the answer by 2. And next is the common mode. It does the same process in the differential mode, but instead of subtracting, we add side A and side B. Now, this is what I mean. This is the side A or the A side, and this is the B side. This is the differential mode, and this is the common mode of the digital signal. This is a sample waveform diagram of NBDS. We are going to read this input signal by basing which is higher, the sawtooth or the analog waveform. So first, since in this part, analog is higher than the sawtooth because the sawtooth is here and here. They intersect in this part. So from this point up to this point, we have a positive 1 value for side A or A side. By the way, this is the equivalent output of side A and the side B. It's differential mode and common mode. So from this point up to this point, it is positive 1. It is positive 1. And when it reaches this point up to here, the sawtooth wave is higher than the analog. So it is going to be a negative equivalent of A side. And next, how do we read the B side? B side is represented by this another analog wave. So from this side up to this side, it is higher than the sawtooth. So it is positive. And from this point up to this point, it is going to be the negative equivalent of our analog or B side since the sawtooth is higher. So, and for the differential mode, we derive the differential mode signal by subtracting the side B from side A and getting its average. So first is we have here 1, positive 1, minus 1. So that would be 0. So at this point, the differential equivalent is 0. And from here up to here, we have A side of positive 1 and B side is negative 1. So 1 minus negative 1 is equals to 2. And we need to get its average. So 2 divided by 2 is equals to 1. That's why its voltage level is 1. And next is, in A side we have the value of negative 1 since it is the invert of the waveform from the analog. So negative 1 minus negative 1. Negative 1 minus negative 1 is 0. That's why we have here the output voltage level of 0. And for the common mode, the process is the same from differential mode, but instead of subtracting, we do addition and we add the side A and side B. So on this side, we have the positive value or positive 1 from side A and also positive 1 in side B. So we're going to add 1 plus 1, that would be 2. And we would also divide it by 2 to get the average. So we have here a value of 1. This is its first voltage level. Next is the value of positive 1. It's also a positive 1 in A side, but in B side it is negative 1. So positive 1 plus negative 1, it's going to cancel out, which is 0. So we have here the value of 0. By the way, this is 1, 0, and negative 1. And next is we have a negative 1 value in A side and also still a negative value from B side. So negative 1 plus negative 1 is negative 2. So we got its average is negative 2 over 2 is equals to negative 1. Negative 2 over 2 is equals to negative 1. So we have here the value of negative 1. That's how we analyze the output waveform of NBDS. Again, from here to here, it's going to be positive 1. And from this point to this point is negative 1 inside A. And from this point to this point is positive 1 of the side B. And at this point and this point is negative 1 of side B. And we subtract the values and get its average to have the values in differential mode, and so on. And for the common mode, we add the values and divide it by 2 or get its average to have the value in common mode. As what we noticed, the width of the pulse on our waveform changes in accordance with the given signal. Here, if the signal is from this point up to this point, its digital average is going to be wide since it's from here up to here. But once our analog signal is narrow, just like for example is in here, it's from here up to here, we have here a narrow digital equivalent. So that's how it works. It is because the amplitude of the signal changes and the width of the signal will change too. It can be wider or narrowed. That's all. Thank you.